and welcome to Teaching Elixir. We will be going through comprehensions this time as we start wrapping up the process of teaching Elixir to my developer friend, as he's actually going into work with Elixir. I think we'll finish up the basics of Elixir School. That's the idea. We are skipping a few that will not make sense in live book. So probably skipping documentation, testing, mix, might be a few of the others. But we'll try to wrap up at least the basics section, and then I think we'll have a few fun diversions, and then we'll see if we do anything beyond that. But this time we're doing comprehensions. Hey, Andreas.
Good morning.
Good morning. So, comprehensions, what's that?
I don't know. I don't comprehend.
Oh, haha.
Yeah.
But you've done a lot of Python, and I
I've done
know
a lot of
Python
Python.
has list comprehensions and dictionary comprehensions.
And set comprehensions, because why not?
Sure. And to my knowledge, that's mostly a way of turning a list into another list, or turning a dictionary into another dictionary, or something akin to that.
Yep. You can turn anything you can generate or you can iterate over into something else that can be iterated over.
Yeah.
The most powerful one, I think, are the generators. But we're not going to talk about Python today, right?
Hopefully not too much.
Cool.
So, list comprehensions are syntactic sugar for looping through enumerables in Elixir. In this lesson, we'll look at how we can use comprehensions for iteration and generation. So, Elixir has a for loop, which isn't a terribly functional programming thing to have, in my understanding. Typically, what you would use a loop for in functional program. So, a loop, a while loop, a for loop, or for each in some languages, is typically used to iterate through an array or a certain number of iterations in most languages. And in functional programming, since you can't sort of just increment a counter and keep going through the indexes in the same way because of immutability, you tend to do these things with recursion. You tend to need to do them with recursion, and sort of enum map and enum reduce in Elixir, or fold left, I guess, and fold right and map in some other languages.
Yep.
Typically handle those cases. So map turns, an enumerable, but typically a list, into another list with the same number of items, while a reduce or fold operation can actually reduce the number of items. It can compact them into one item. It could build a list of fewer items or even more items.
Yep.
So that's sort of how iteration typically works in functional programming. So for loops, as far as I know, they're implemented as macro in this case. And they allow going through any enumerable and producing any collectible, but typically they produce lists. And I will say I don't use for loops all that often, mostly because they are a little bit of mystery meat in my book. But let's see what they can do. So looking here, filters. You can think of filters as a sort of guard for comprehensions. When a filtered value returns false or nil, it's excluded from the final list. Did it really start with filters? It did not start with filters. Did I accidentally edit? Oh, yeah. I accidentally clicked the button when we started. There, basics. Let's start with basics. That's better. I accidentally hit one of these down arrows, so it just jumped down.
Oh,
But I
there are
thought,
buttons to reorder the sections.
yeah. So I
haven't
thought
seen
I
that.
just accidentally made myself scroll down. I didn't realize it reordered the whole thing. Cool. Basics. I think this is a better place to start.
Yes.
I thought filters was a weird place to start, and it wasn't. When I did the edit pause on the document, that's not what I saw. Comprehensions can often be used to produce more concise statements for enum and stream iteration. Let's start by looking at a simple comprehension and then break it down. So we create a list, 1, 2, 3, 4, 5. We go 4, X, backward arrow, list, do. And this could be a full length do block with a do and an end. This is just a single line do block.
Yep.
Comma, colon instead.
Yep.
And it will multiply x by x, producing 1, 4, 9, 16, 25.
Yes.
Does this seem straightforward?
Yeah, I find the syntax weird, but
Because of the backwards arrow?
yeah, it's
I think it means generator. The first thing we notice is the use of for and a generator. What is a generator? Generators are the x, arrow, 1, 2, 3, 4, 5, and 1, 2, 3, 4 expressions found in list comprehensions. They're responsible for generating the next value. Lucky for us, comprehensions aren't limited to lists. In fact, they work with any enumerable. Something I'm curious about here is, can you actually use a generator outside of the constructs that I know use generators?
Mm-hmm.
So if I just want to generate foo, no, that's an undefined function. So because you'll see those arrows in two places in Elixir in my experience: for loops and with statements.
Okay. Both of them are macros, right?
Yeah.
Yeah.
Or I assume the with statement is a macro. It looks like one. All right, but let's look at some other examples. So keyword lists. These are the structures in Elixir which are essentially just a list with two tuple items where the key of the tuple or the first item of the tuple is an atom.
Yep.
So something is not a keyword list if those criteria aren't met. But if you do enum map on a keyword list, you get a key and a value tuple for every item.
Yep.
That's also what you get if you for comprehend them.
Cool. Okay, let's do this.
Yeah.
Cool. Yep.
Keyword list can have duplicate items. They're just a
Yes.
list under the hood, which is useful for certain things where duplicate items are actually a thing. I think HTML header or HTTP headers can duplicate.
Also, HTTP forms or query strings.
Yeah.
And stuff.
Then again, for HTTP headers, you do not want to use a keyword list. You'll probably just use a list because you want string keys. You don't want atom keys.
That's a very good point.
And then for maps, you get the same kind of behavior, regardless of what kind of key the map is. They turn into tuple items.
Mm.
And then binaries. This is some syntax right here.
Yeah.
Just arrows around the entire generator, and then return a binary of the. Actually, what happens if we do this? I bet we get numbers, right? No. Oh yeah, then it turns to the Erlang char char list. Hello.
I think we have a dog in the recording.
Yeah.
Yeah.
You have some background dog. I think it's fine.
Very good. Don't mind the dog. She's barking at something important.
Yeah. Very excited about something.
Yep. Probably a cat.
Like many other things in Elixir, generators rely on pattern matching to compare their input set to the left side variable. In the event a match is not found, the value is ignored. So that's interesting.
Mm-hmm.
So this is a keyword list with OK and error tuples.
Oh. Nice.
That's a little bit useful, but this is sort of where it gets a little bit too capable for my taste. Where it's like, but do you actually, as a user of comprehensions, or rather as a reader of the code 2 weeks later, remember the exact behavior of the pattern match in for loop? Like, will it throw or will it filter?
Yeah, I think I would prefer to use the filter function.
Yeah, that's typically what I end up doing. Like, yeah, a chain of enum map, enum filter, enum da 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 is very explicit.
Yeah.
It's very, very easy to understand. But
And
these are certainly neat. So I definitely use these when I needed to do things in a pixel grid when I was building an e-ink display library.
Oh.
Because then I could just for comprehend the x and the y axis, and then it in that way iterate all of the pixels, because it wasn't that big a display. It wasn't that heavy.
Yep.
So you can see this case actually covers that approach to some extent. It's possible to use multiple generators, much like nested loops.
Yeah.
So here nlist n times. And so if we wanted to turn these into pixels rather, it would be n times. And we would get a list of coordinates. You can also, like, typically I would see this written as like this, like so, and just line break it.
Oh, this will be interesting.
Yeah, now they do puts.
Yep.
Okay. Because IO puts returns okay, and that has never bit me ever.
It needs to return something, right?
Yeah.
Yeah.
And it's usually okay.
Yeah.
So functions that don't explicitly return anything return nil. So.
Oh.
So filters. You can think of a filter as a sort of guard for comprehensions. When a filtered value returns false or nil, it is excluded from the final list. Let's loop over a range and only worry about even numbers. We'll use isEven function from the integer module to check if a value is even or not.
Yep. Good stuff.
Like generators, we can use multiple filters. Let's expand our range. And then filter only for values that are both evenly divisible by 3.
Yeah.
So these are also nice and sort of terse, but I don't find them that helpful to read.
No, it takes a surprisingly long time to read them. Much longer than reading a filter function.
So it's super powerful, and I guess the for loop can also be a little bit smarter. I'm not sure how smart it actually is about sort of compacting operations and stuff.
What does it translate into?
I mean, it's a macro, so it's just
Anything.
No, but I would guess it performs a series of either enum or stream operations, and which ones would depend on what you're giving it. But then so now everything has produced a list so far. Now we're using into.
Yep.
So now that means into accepts any structure that implements the collectible protocol.
Yes.
Using into, let's create a map from a keyword list. So we can see here, this is a comprehension, and it's passing the into keyword.
Mm-hmm.
And an empty map and evaluating that. Assuming it gets tuples with keys and values, it will nicely. Yeah, didn't actually know if that would happen, but yeah, it would.
It could have been that it wanted a constructor or something too, but apparently it just wants something. So this looks quite a lot like a fold or a reduce.
Yeah. And I will say, like, if you need to produce a map of something, this has a little bit fewer moving parts than reduce.
I don't agree, but sure.
So for every iteration of a reduce, you also get the accumulator and need to put things in it.
Yeah.
So that's a lot more explicit, and this can be a little bit tighter. But you can also just do, so there's two different ways of doing this that I commonly use. So there's enum.into, which is a function that takes a collectible and shoves a list into it.
Yep.
So it does exactly that. And then you can just do enum into and pass it a map. Or you can just send your list into map.new. And it will also do exactly that.
Cool.
So that's typically what I do rather than this.
Yeah.
Also, again, explicit. That's my preference. This is like for loops are super cool if you really like writing dense, clever code, but that's not my preference.
Oh, well, expect to see them from me then.
It doesn't sound like you're very into them though. So
No, I'm slightly sad that I don't fall in love with them immediately. Because I love clever code due to you. And people who read my code don't love that I love clever code. So
well, since binaries are collectibles, we can use list comprehensions and into to create strings. That's a interesting sentence. Since binaries are collectibles, like,
yes.
Do you collect binaries?
I do actually. I have a whole locker filled with binaries. They aren't in the best shape because I haven't really taken care of them properly, but I do collect them.
This putty.exe is only in fine condition.
Yeah.
It has bit rot.
Quite a bit, but you should have seen it when it was new.
It was great.
Yeah.
That's why you shrink wrap software.
Totally.
All right.
So
that's it. List comprehensions are an easy way to iterate through collections concisely.
Cool.
And
Can we implement FISPAS using comprehensions?
I guess you could. Well, that one FISPAS wants you to perform an operation regardless of what the thing. So whatever the value is, you're supposed to print something.
Yeah, but that's in the end.
Yeah, but you couldn't use sort of the filtering function here.
I think we could.
Because it will remove items.
Yeah. Well, let's try this. I'm gonna do something.
Yeah.
Okay. So we have a list of all. Can we make a list of all numbers like this?
Yeah.
All numbers from 1 to 100.
You can just remove the list syntax around it.
Like that.
Yeah. If you remove the for loop and just press Control Return, you'll get to see the output of your range.
No.
Boom! It outputs a range, which I think is a stream. So.
Okay, whatever. Like that. Now we should get something that we can do something with, and then we can.
Yeah, you can do a do end block. So
there we go.
Yeah.
Okay. Filters. I've totally forgotten now to filter. Like add a comma after here. Maybe we can.
Yeah.
And I want to have one of those spicy anonymous functions, I think. No, I want to do a rem I3 like that.
Mm.
No, I didn't.
Unexpected keyword do. You want to comma after when you're doing a compressed single line thing.
So that didn't work.
No. But you need to return a Boolean, so you need to compare it to something. No, not inside the rem.
Almost. Like this.
Yeah.
I want to add an or here. Can I do just...
Yeah, you can
Let's
do
find
an
out.
or. That should work.
Okay, that works. This is the first part of the FizzBuzz. And now I think I want to put something here. How did I do block? Just do...
Remove the comma, remove the comma before the do. Enter and end. There we go.
So, okay. And are if expressions just if?
Yeah.
Cool.
You can, of course, also do a case if you like.
Yeah. Yeah, I think I want to do a case. It depends. Case I, and then new line.
Do.
Thank you. And... Okay.
So what do you
no,
want to do with
want
this
to do
I
an
now?
If. I'm terribly sorry. If rem I 15 equals 0, is it a do here?
If you want one line, it's comma do colon. If you want multiple lines, it's...
Multiple lines are cool.
Yeah, you probably want to else it as well, so...
Yeah. Like that. Are there else if things? Like that? No?
I don't think...
Like that?
Yeah, maybe. Probably.
Let's find out.
So rarely use them. So, this is actually a good case for the cond statement.
Oh, cool. Okay. How does that work?
So, let's do... That's a cond do block. So you don't pass anything in.
Yep.
And then you do rem I 15 equals arrow
Maybe a zero.
fizz buzz. And the catch-all will be true.
Yep.
I don't remember the criteria for fizz
Oh,
buzz.
I can write the rest of it.
Yeah.
So 3 equals 0. I don't remember which of them is fizz and which of them is buzz, but that doesn't matter for our demonstration.
Uh-huh.
It's if the viewer knows.
And for anything else, we're supposed to print the number, right?
Yeah, so then we can return I, right?
Should we return the number?
Yep. Let's do it like this
Okay.
and see what happens.
Because now you've filtered on 3 and 5 already.
Yeah.
Which doesn't really help us.
Okay, then we remove them.
Yeah. And see, this was why I said you probably can't quite do it with...
You're only seeing problems where I'm seeing solutions. Okay, I think we just implemented a rather bad version of FizzBuzz.
Yeah, I think there's also... I think you're actually supposed to always print the number, but print fizz and buzz when you hit those. I don't remember the exact criteria, and I just know I've screwed it up once when I was fizz buzzed during at the end of an interview for a senior position, where we hadn't done a line of sort of code interviewing, and I was mostly sort of blindsided and very surprised that he would pop that after an hour of architectural discussion. And then I was a little bit insulted after the fact. Yeah.
Yeah. Okay, so yeah, cool. Well, this I thought it would be a much better fit for the comprehension, but it wasn't really.
Yeah, so I don't think it can really do a really good job of that, but yeah, it's a good little exercise anyway, and it's one of the rare cases where I think the cond statement is super useful.
Yep.
It is useful. I'm glad it exists, but cases are almost always the correct choice.
Totally.
Personally, I almost prefer case statements even when an if is the correct choice.
Yeah.
It's almost like, yeah. So I think for comprehensions at their most basic level, like we're using it here, just a simple loop,
Yep.
is a very nice on-ramp when you're coming from other languages and other paradigms, so OOP or procedural styles, where you're looking for a loop. You really want a loop, and the for feels comfortable.
Yeah. So otherwise, let's see, you would use an enum map here, right?
Yeah, this would just be an enum map.
So
And some
Yeah,
people
it's
say
so
that you're not supposed to pipe into so case statements and stuff. But like, I think that's sometimes fine as well.
yeah.
Or I like a pipe into a case statement, honestly, but I can see that maybe that's not ideal all the time. So, oh, what happened there?
What did
Oh.
it do?
Well, I tried to. I think I just hit undo instead of the cut.
Yeah.
But so this would, I guess, be the same. Yeah.
Cool.
And if I want to tack on sort of filtering or
Print
enum
it.
filter,
Print
I
it
could do
all.
that here. If I want to end it with a map, I could do map.new. But that's not going to work for this because, yeah.
Indeed.
And since this is just one value, since it's not actually a pipeline, I would stop undoing. That's not what I'm trying to do. Then I would just move this into here.
Yeah.
Otherwise, Credo would shout at me. And Credo is one of those best practice analysis tools. And I tend to just roll with its opinions.
Yeah.
So I don't have to configure it specifically.
Indeed. Cool.
Cool. I think we'll drop this fizzbuzz and call it a day.
Totally.
Good job. Delete section. Delete all cells in this section. Oh yeah. Gone. Boom.
No more fizz buzz.
Yeah. Thanks for watching. Let's actually take a quick look at what's probably next. Well, there's strings and there's date times, and I think those are what we'll probably get into. And then we might be doing some final exam stuff for Andreas.
Sounds good.
And then maybe I learn something. We'll see. Thanks for watching.